A couple of minutes and walk you through the first technology assignment. So what you're going to do is go into technology assignments and scroll. You should definitely read through the expectations page. You can see the rubric, and so this gives you an indication of how things will go grade-wise. But the priority for this video is Tech Assignment A. All right, so due date midnight on the day before, unit test 1, 20 points possible. You're going to post a share link to Blackboard. I'll show you how to do that in a minute. Criteria, grading rubric, a little blurb about the importance of these things. But I'll summarize it by saying that the main idea, or at least my thinking behind technology assignments, is to kind of give you a little bit of exposure to some of the different applications, technological applications of the things that we're learning in class. Right? In a lot of ways, it's a visual representation that you wouldn't necessarily get with just using a calculator, all right? A regular TI calculator. All right, so on your to-do list, you'd watch the instructional video. All right, well, you're already here, so I would imagine you've already navigated to this. Work through the assignment. Participate in the discussions. There will be a discussion every time there's a tech assignment. There's a corresponding discussion. So you want to make sure that you adhere to the requirements of the discussion board for the tech assignment. And then, if there's any constructive criticism offered, graciously accepted. I'm sure that's pretty standard, actually. And then make sure you get your assignment turned in by the deadline, and you can expect that I won't be looking to find fault. All right, that's general rule of thumb, is that I look for the good, not the bad. So if you're trying your best to do the assignment in the spirit of the assignment, then you can expect full credit. If you try to cut corners, then that's a different story. All right, so we'll click on the attached files. We'll click on the assignment itself in a little bit, but I'm going to do a command click. All right, and so that'll bring us to the actual tech assignment. All right, so you go to desmos.com/calculator and either log in or create an account. You got to make sure you're logged in. All right, because you're going to create a share link out of this, and if you're not logged in and you don't have an account, there's nothing that your work will be linked to, and I won't be able to access it. All right, and so I'll open it or try to open it, see nothing there, and you'll say, where'd my work go? So you want to be careful about that. All right, watch the video in the overview. So again, we're already here, so that's irrelevant. Click on the following link. This is going to be important. I'll show you that in a minute, because all of the work that you're going to do is going to be saved in that link. All right, make a copy by clicking the title of the Desmos. I'll walk you through that. Replacing your name here with your actual name. Then there's a table that assigns you a function based off of your last name. There's going to be some overlap. There's plenty of students, I would imagine, that have last names beginning with the letters A through F and G to K and so on. All right. So what I'll do is I'll just create an example on my own, in my head, and I'll just do that. But you would choose, you don't have to do all these functions, just the one function associated with your name. All right, so that should be pretty clear. If you have any questions, message me on that. All right, and then create a share link. All I want is the share link so that I can go into your Desmos directly. All right, so click. Here's your Desmos. I'm going to put a function in, and let's say my function is 2 to the x power. So, but I'll read through or 2 to the t power, apologies. This Desmos is a tool designed for us to gain a little space issue there. All right. Deeper understanding of the fundamental theorem of calculus, part 2. All right, that's not there to confuse you. It's not the second part of an activity. It's the second part of the fundamental theorem of calculus. All right, but before I forget, I'm going to click on this, and I'm going to change it to my name. And so now any changes I make will be, because I'm logged in, you can see it right here, Theodore, that's me. I'm logged in. Any work that I save now is going to be my own work. All right. You need to refer to the companion document for your function. So you look at the chart, you see where your name corresponds to a function, and you type it in. So mine's going to be 2 to the t. I'm just making that up on the fly. And you see a nice 2 to the t graph comes up. All right. Since Desmos will not evaluate multivariable expressions the way we do, we will let the slider n take on the value of the upper bound of integration x. All right. So I'll just keep reading. Move the slider and use the resulting areas to fill in the table that follows. So this part is a little tricky. It's painstaking, but it's got a good payoff at the end. All right. Analyze the resulting plot to find a function or family of functions that models the data. All right. So you can see here as I slide along, you see that integral function, a equals blah 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 f of t dt. That's giving you the area between 0 and whatever we decide on as the n value. All right, that's fundamental theorem. So what I want to do is put in my n values and my a values as ordered pairs. But wherever possible, I'd like to get some convenience here. All right. Now, you can get a little sneaky. I don't want to say cheat, but you can get a little sneaky if you know the actual exact value. Then you can go that route. But in the spirit of the assignment, you should go with the decimal value. Right? Now, you don't have to put the entire decimal in, but you could. Right? So if you wanted to do that, then when I go to, and I'm going to try to choose convenient values here. I mean, it's 2 to a power. You know, if it were just evaluating 2 to that power, that would be easy. But it's the area under the curve between 2 and that power. So that's a little funkier. All right. So let me show you how you can get the exact, well, quote unquote exact value. Just a command C. I'm using the Mac, so command C or control C. Type in the 1, and then command V or control V, and then pop the whole thing in there. Or you can just ballpark estimate. I just kind of find that once you get in a groove, you're able to draw conclusions pretty easily. But the thing that's going to take the most time is the data entry. And it's like, it is what it is, but you kind of get used to it. And you develop a little muscle memory, and before you know it, you're kind of in a groove. But you can choose as many points as you want, or as few points as you want. The idea, though, is to be able to develop a trend for the data. And once you do that, you can stop putting points in. Also, I mean, it does kind of get out of hand pretty quickly. Now, relying on our knowledge of exponential functions, now that's only going to help me here because I chose an exponential. All right, but if you use the trig function, you'd possibly rely on some knowledge of trig functions or, polynomial functions, whatever. I know that derivatives and antiderivatives of exponential functions involve exponential functions. So I'm going to kind of keep that in mind as I go forward. All right, but I'm going to only put in these 4 points. By the way, I neglected to say this, but maybe you noticed it. I was pasting in my y1 values, but my x1 values were auto-populating. Desmos recognizes trends. So if you're going by half units or quarter units, once Desmos recognizes what you're doing, it'll start auto-populating the next value for you. All right. So using the trend observed in the scatter plot generated by the data table, that's the blue points, determine the function or family function of functions that models the data best. If a trend is not obvious, include more data points in a table. If there is an obvious trend, but the curve doesn't fit perfectly or near perfectly, include more points in the table. So, if I couldn't tell what it was, I concluded it's exponential, then, like if I couldn't make that conclusion, then I would add more points and see if maybe I can pull it out from there. All right. Then there's some follow-up questions that we have to get into, but let's let's focus on this. Now, you may have noticed that there was this little tab here that said shading. All right, this this involves some integral calculations. I just realized that there's a slight error. These A values should be N values. I never changed that. So if you could actually make that adjustment on yours, that would be helpful. But it's really not. The reason why I glossed over it is it wasn't really necessary. All right, because you can see that the shading will change correspondingly. All right, but what I'm going to do is turn those off, because it wasn't really, like I said, it wasn't really necessary. It was just something I kind of did for fun. All right, so the best fit model, I'm going to say, is exponential. All right, but now I actually want to find the best fit model, the actual best fit model, if possible. All right, so what do? Well, Desmos understands regressions. All right, so it understands it in a kind of peculiar sort of way. So instead of writing y equals whatever, we're gonna go by the notation used in the table here. I'm gonna type in a y1. All right, now it just tells me there's a 4-element list. That's wonderful, but that's not what I need. I'm gonna use a tilde. That means regresses, or at least Desmos interprets that as regresses to, and then you just type in a model that can be used to represent the data. All right, so let's say, for example, I thought it was linear, and it's in the form of a plus bx. A plus b, now it's not really x, it's x1 based off the table. Now that's not really a good fit for the blue points, right? And you could tell by the r squared value. I mean, r squared actually makes it seem like it's a pretty good fit. The closer the r squared value is to 1, the closer it is to a perfect fit. All right, but since we know it's exponential, we know there's a better option out there. So you might try something like quadratic. All right, a quadratic model, you know, quadratics, ax squared plus bx plus c. So you would try ax1 squared plus bx1 plus c. You see that that's a much better fit. It's capturing a lot more of the points. All right, and so if you thought maybe it's a quadratic model, then you might go with this. All right, I will say that I'm not looking for accuracy as much as I'm looking for a reasonable attempt at accuracy. So it's the investigation, not just the answer. All right, so if you type in, for example, y equals 1 over the natural log of 2 times 2 to the x power, that does nothing for me. All right, the idea is that you've attempted to follow the technique, the investigation, because what I want you to have is a resource going into the future where you could say, I have no idea what the derivative or antiderivative is, but I have a method that I can use to kind of parse that out. All right, so that's important. And so that's what I mean by the spirit of the exercise. So it doesn't have to be 100% right. I mean, you look at this and say, it's all 0.9983. That's really good. I know that there's a better one out there, but maybe you don't, and that's okay. All right? Because if you put an answer here of quadratic and then show a quadratic regression, you've done your job. All right? But I think it's exponential, so A times, oops, I hit cap lock, times, I'm using, by the way, keyboard shortcuts. So like Shift 6 for the caret to get an exponent. When you type in x1 or y1, it's just the x and the y with just a 1 after it. All right? But if you're unsure, you could always select the show keyboard. And the subscripts in the actual QWERTY pad, you see the A sub B? That'll get you where you need to go. All right? But you know, I have enough experience with this that I tend to go with the shortcuts. All right? So A times B to the x power, so x1 power, is an exponential relationship. Now, even this is not showing a perfect fit. But this is the one I think is it. All right. So 0.9915, that's very nice. All right. Now, if you really want to get a good close look at it, you see it's grabbing all of these points. It seems like maybe that zero's throwing everything off. Well, it kind of makes sense that maybe the zero never needed to be there to begin with. Because wouldn't zero be part of the set for pretty much all of them? If you're not accumulating any area, would you... I'm sorry, if you're not accumulating any horizontal distance, would you ever accumulate any area? No. That would be the same for every function, but not every function goes through the origin. So let's actually get rid of the zero and see what happens. All right. So you get rid of the zero, and now we're up to 0.9975. Still not perfect, but a little bit better, and it goes directly through, well, as directly as we can get, through the 10. Pretty close here. Pretty close there. I'm sure if we add another point or two, we can probably get even closer. So let me get this up to 4. See, this is what I mean by an investigation. You know, it's not a matter of just saying, oh, there's a right answer. Why do we have to do this? I know what the antiderivative is. It's not the point. All right. So I got this one in there. 9983, slowly but surely. Hit enter. You see it auto-populates to 5. 9992. The more the merrier here. Put in a 6. It's getting better and better. Maybe even one more. Let's get this up to a 7. Oop, just kind of moved on me. 183. Now that's going to be off the grid, but that's okay. Desmos doesn't have a problem with that. Okay, let's see. 0.9999. I mean, I don't know if we'll ever get to a 1, but I'm going to give it one more value and see. Oh, look at that. It's a 1. Perfect fit. Seem otherwise, but I'm going to chalk that up to perhaps this being a rounded value. You know, something that rounded to 1, but I'm happy. The fact that it got me to a 1 is a good thing. All right. Now, if I want to create a function out of this that could be manipulated, what I can do is type this in. I'm going to call it g now because we've already used f. G of x is equal to a times b raised to the x power. Hit enter. Well, and then delete the extra space that comes up. Now you see if you toggle these on and off, you can see that it's giving you the same graph. The thing is, if I wanted to make a substitution in here or, you know, manipulate this in any way, I can do that. This one I can't. All right. So, no, I went the wrong way. Apologies. When we computed the area, we assumed a lower bound of integration of 0. If the lower bound of integration were something other than 0, how would that impact your best fit model? So that's something you'll have to investigate. I'm just looking for a brief answer here, nothing too crazy. What is the derivative of your best fit model with respect to n? All right, so our best fit model, we wrote it in terms of x here, but these are really n's. Because when you anti-differentiate here and get the values that make up the table, I mean, we played around with different notation here, but it's a in terms of n. So we wrote g of x in terms of x, but this is a in terms of n. So you got to imagine that the g of x is an a and the x is an n. So if I want the derivative here, I'm really just finding g prime of x. Now, looking at this is really cool. I'm going to turn this one off. I have my g prime of x on here. And my original function f of t is 2 to the t. That's really cool. All right. So what Desmos is trying to tell me is that, okay. I mean, we could say, what's the derivative of my best fit model with respect to n? Well, it's g prime of x. I mean, that's not really answering the question. The answer really is that it's 2 to the whatever power. You know, like in this case, we used a t. We're differentiating with respect to n, so it now becomes 2 to the nth power. All right, so it becomes 2 raised to the nth. We could write it like that. You can write it in a new space. You can write 2 to the nth. All right, it gives a numerical value here, so that's a little bit confusing. I prefer to answer it right in the line, though. So 2 with a caret is fine to the nth. All right. So since Desmos will not evaluate multivariable expressions the way we do, we let the slider n take on the value of the upper bound of integration x. That's the second fundamental theorem of calculus. All right. So with that in mind, what's the derivative of your best fit model with respect to x? So pretend that, just go right back to the beginning, pretend all these n's were x's. What would you get? Well, we just said it was 2 to the nth. That would mean it's 2 to the x. All right, same function. You could write it as y equals if you want, but 2 to the x is fine. How does that compare to your original f of t? I'm giving it away here. I'm giving you the final answer. I have a 2 to the x. I have a 2 to the t. They appear to be exactly the same. All right, so, and that's going to be pretty consistent with the different functions that I've assigned. All right, I didn't go into the realm of complicated chain rule or anything like that. All right, so we have that part of it. Now, in order to submit your answer, so really the only thing, apologies, the only thing I'm really leaving you to figure out on your own is this part here. So I kind of walk you through the investigation. I know it's a lengthy video, but you know, it's the first tech assignment of the course. It's worth spending the time on, I believe. All right, you could always fast forward me too and skip around. Anyway, to submit, you see this little share icon here, share graph. It's not just the picture. You get the commands that along with it. Select copy. So copy that share link. It only works if you've saved. So save your changes first. It only works if you're logged in. So make sure you're logged in. Then copy. Then you go back into your tech assignment. So click on tech assignment A, and you'll see, you know, the whole rubric thing, the assignment and everything. You'll see a field where you can, or an option to write a submission. In that write a submission, Control V, Command V, whatever device you're using, paste in the link. That's all I need from you. All right. So then just hit submit and you're good to go.